So what is RAG? RAG stands for Retrieval-Augmented Generation, and RAG is used in real AI systems. That is, most serious AI applications today rely on RAG. And why do we need RAG? Because large language models are good at reasoning and writing, but not always accurate with facts, right? So how does RAG help? RAG connects the model to external knowledge sources so it can check facts and give up-to-date information. Okay. With this background, I have put together the questions that are perfect for interviews or as a checklist for understanding RAG. Okay. And each answer shows how skilled RAG engineers think about these systems in practice. So let's get started with the interview questions. Okay. Let's understand what problem does RAG solve that standalone LLMs cannot. LLMs rely on training data, and when we use LLMs alone, they generate answers based on patterns they learned during training and the input prompt. And LLMs don't have real-time or private data. That is, LLMs cannot access your company data, latest updates, or private documents on their own, right? And LLMs guess when unsure. That is, if the model doesn't know something, it still tries to answer. This can lead to incorrect or made-up responses, okay? Whereas RAG adds a search step. That is, RAG first retrieves relevant information from real sources like documents or databases before generating an answer. So answers become more reliable. That is, instead of guessing, the model uses actual data to produce accurate and trustworthy responses. That means RAG replaces guessing with real information, and also RAG makes AI answers more accurate and dependable. Okay? Next one, how does a RAG system work end to end? The first step is to build the knowledge base offline. That is, we start with documents. These documents can be PDFs, websites, company data, or any text sources, okay? And then clean and organize the data. That is, remove noise, fix formatting, and make the text easier to process. After that, we split the document into chunks. That is, we break large documents into smaller pieces so the model can handle them better. And we convert text into embeddings. That is, turn each chunk into numerical vectors that capture meaning, okay? And then store it in a vector database. That is, save these embeddings so they can be searched quickly later. So this is the first step, okay? And the next step is answer a user question online. So the user asks a question. That is, this is the input to the system, okay? Then convert the query into an embedding. That is, the question is also turned into a vector. And then retrieve relevant chunks. That is top K. Okay, that means find the most similar pieces of information from the database. And the optional step is to re-rank results. This improves accuracy by reordering the most relevant chunks. And then build the prompt. That is, combine the user's question with the retrieved context. After that, LLM generates the answer. Okay, that is, the model uses both the question as well as the real data to respond and finally return the final answer with sources. That is, the system outputs an answer, often with citations for trust. Okay, so RAG works in two phases. Prepare knowledge first, then retrieve and use it to generate accurate answers in real time. Okay, now let's understand what the retriever and generator do in RAG. Retriever is the search engine. That is, retriever finds relevant information, and the retriever searches the database and pulls the most useful content related to the question. Okay, and it brings candidate answers. That is, these are chunks of text that likely contain the answer. Okay, and the generator is the answer creator. It uses the retrieved data. That is, the generator reads the context provided by the retriever, and then the generator creates a final answer. That is, it combines the user's question plus retrieved information to generate a clear response. Okay, now let's understand how they are connected. So they are linked through the prompt. That is, the retriever decides what information goes into the prompt, and also the retriever controls what the model sees. If the retriever misses any important information, then the generator won't know it exists, right? So both must work well together, okay? And if the retrieval is bad, then even a strong model gives wrong answers. If the generation is bad, then even good data leads to poor responses, right? That means the retriever finds the right information, whereas the generator turns it into the answer. And both must work together for RAG to succeed, okay? Next one, how does RAG reduce hallucinations compared to pure LLMs? LLMs usually guess answers. That is, without RAG, models generate responses based on patterns. So this can lead to made-up information or incorrect information, whereas RAG provides real evidence That is, it retrieves actual text from documents or data sources, so the model can use. Okay, and also RAG answers are grounded in facts. That is, instead of inventing details, the model summarizes or quotes from the retrieved content. So RAG shifts from guessing to citing. That is, RAG does not fully remove hallucinations, but it makes the model rely more on real information than guesses. Okay, and also with RAG, you often get sources along with answers. That is, many RAG based systems include citations, so you can fact check the retrieved information. Okay, and the real world example is tools like Perplexity. Okay, they use RAG to provide answers along with sources that makes the results more trustworthy, right? That means we understood that RAG reduces hallucinations by grounding AI responses in real data instead of relying on guesses. Okay. Next one, what types of data sources are used in RAG systems? We use internal documents, that is, company knowledge like wikis, policies, and product requirement documents, PRDs, and also files and manuals, that is, PDFs, product guides, training materials, and reports. Okay. Another data source is operational data. That means support tickets, CRM notes, and internal knowledge bases used in daily operations. Okay. Another source is engineering content, that is code, README files, and technical documentation used by developers. Okay. Another one is structured and web data, that is the data from SQL databases, JSON files, APIs, and web pages. That means RAG can use almost any data source, and RAG turns all your company knowledge into searchable intelligence for AI. Okay. Let's understand what is a vector embedding and why is it important. Embeddings means converting text to numbers, right? That is, a vector embedding converts text into numbers so the machine can understand. Okay. And also it captures meaning, not just words. That is, similar meanings are placed closer together even if the exact words are different. And also closeness equals similarity. That means texts with similar meanings are geometrically placed closer to each other. Okay. And vector embedding is used in dense retrieval. That is, instead of matching keywords, the system finds content that means the same thing. Okay. Also, vector embedding handles different wording too. That is, even if the query and document use different words, embeddings can still match them correctly, right? That means embeddings turn meaning into numbers. And also, embeddings allows RAG systems to find the right information even without exact keyword matches. Okay. Now, let's understand what is chunking and why does chunk size matter. So what is chunking? Chunking means breaking large documents into smaller pieces. These are called chunks, so they can be stored and searched easily. And why do we need chunking? Because LLMs can't process huge documents at once, so smaller chunks make retrieval faster and more accurate. Okay, and choosing the right chunk size really matters. That means if chunks are too large, then you get too much unnecessary information and the exact answer may get buried, right? Also, it wastes the model's context window, and if chunks are too small, then the important context is lost. Okay, that means good chunking balances size and meaning, and the chunk should be big enough to keep context and also small enough to stay precise. All right. The next one is, let's understand what's the difference between search and retrieval in RAG. Search is keyword based, that is, it matches the exact words, and search looks for documents using keywords like BM25, and search works best when you know what you need to type. That is, if your query has the right keywords, then the search gives good results. Okay. Also, with search, we may miss relevant content if different words are used, right? And when it comes to retrieval, it goes beyond keywords. That is, retrieval includes semantic or vector search, hybrid search, filters, and many more. Okay. Also, it can find results even if the wording is different, but the meaning is similar. And retrieval involves multiple steps. That is, re-ranking, filter, and refine results before passing them forward. Okay. So, the key difference is search finds documents, whereas retrieval decides what the model actually sees. That is, retrieval acts like a gatekeeper. It controls which information is passed to the LLM. So, search is about finding data, but retrieval is about selecting the right data for the AI to think with. Okay. Let's learn what a vector database is and why do we need it. A vector database stores embeddings, that is numeric representations of text, so they can be searched efficiently. Okay. And what problem does a vector database solve? A vector database allows you to quickly find similar pieces of information based on meaning, not just keywords. Okay. We use vector databases for fast similarity search. That is, it uses techniques like nearest neighbor search to instantly find the most relevant chunks. Okay. Also, vector databases work at scale. That is, as your data grows, a vector database keeps searching fast and efficiently, right? And it supports filtering and indexing. That is, you can organize, filter, and retrieve data in smarter ways. For example, by metadata, tags, etc., right? And without a vector database, searching through embeddings manually would be slow, inefficient, and hard to scale. So, a vector database makes it fast and scalable to find meaningful information from large datasets using embeddings. Okay? Let's understand why is prompt design still important in RAG. So we know the retriever gives the data and the model creates the answer. But even with the retrieval, the LLM decides how to use the retrieved text, and also prompts set clear rules. That is, we can guide the LLM to use only the provided sources. We can also define the output format we want, right? We can handle conflicting info and also can ask for citations, okay? And also prompts guide how information is presented. That is, the model shouldn't just copy paste. Instead, it should summarize, rephrase, or explain in a structured way, okay? And the other important use of prompts is we can prevent mistakes or misuse. So, a well-designed prompt ensures the model treats context as essential and represents facts correctly, right? So, designing good prompts guide the model to turn retrieved data into accurate, well-structured, and trustworthy answers, okay? Now, let's understand the common real-world use cases for RAG. The first one is using RAG in AI-powered search engines so that the search becomes smarter by understanding meaning, not just keywords, okay? And RAG is also used in code base assistance. That is, it helps developers find relevant code snippets, docs, or examples quickly, right? RAG is also used in customer support copilots. So it can answer customer queries using company manuals, tickets, or knowledge bases. And the other use case of RAG is troubleshooting assistance. That is, it guides users or technicians by retrieving relevant instructions or solutions, okay? The other one is legal and policy lookup. That is, RAG can quickly find clauses, regulations, or policies in large document sets. Okay. Next one is sales enablement. That is, by using RAG, we can equip sales teams with the right product or client information at the right time. This helps the sales team tremendously, right? And the other common use case of RAG is report drafting. That is, it's used to generate reports or summaries grounded in company data. And also RAG is used in Ask My Knowledge Base tools. Okay, this lets employees query internal data as if talking to a knowledgeable assistant. So RAG turns large collections of data into actionable, context-aware answers across industries. Okay. Now let's see why is RAG preferred over frequent model retraining. RAG is preferred over model retraining because updating is faster and cheaper, right? That is, adding or changing documents is much easier than retraining the entire model. Okay. And the next one is scalability. That is, you can quickly refresh knowledge by updating the index instead of the model's weights. And another advantage of using RAG over model retraining is it's safer and auditable. That is, you can track sources, remove bad information, or roll back changes if needed. Okay. And also, retraining is hard, right? That is, training a model takes lots of time, computing power, and effort. And with RAG, we can avoid all this. So, RAG lets you keep AI knowledge up to date quickly, safely, and at scale without retraining the model. Okay.